So I'm going to introduce you guys today to a project I work on called Vital Signs, run by Conservation International. I'll explain the project and explain some of the data we have, and then I'll show you some of the analyses we've done and some of the questions we can answer. So the idea behind Vital Signs is to get a system to integrate data around environments, humans, and agriculture, which is sort of the interface of people in the environment. Right now in Africa, there's a lot of agricultural development and agricultural intensification. Land grabs are happening, and they're pretty well publicized in certain countries. But everywhere, farmers that used to grow subsistence crops are now growing cash crops, and marginalized areas that weren't previously cultivated are now accessible due to tractors and synthetic fertilizers. And this is great for a lot of farmers. It's creating a lot of economic development and a lot of income, but it's also having negative unintended consequences for more marginalized communities and for ecosystems and environments, which people fundamentally depend on. In Africa, people still depend very much on bushmeat, local ecosystem services, soil from wilderness areas. So the idea here is to monitor all this and to get sort of baseline data and to fill data gaps right now where no one's really collecting anything. This project isn't big data in the sense of some of the projects here. We don't have terabytes of data, but this is big data for Africa. We're collecting data that most governments and no one else is collecting. We have a couple of gigs of data from household surveys, ecological data, and one very strong asset of Vital Signs is that we collect all of our data in concentrated landscapes, so we get disparate data types in a small geographic area so that these different data sets can be related and explored. And it's all free and open. You can go on our website right now, vitalsigns.org, and download our data. So the idea behind the system is to measure the variables, to go out and collect the data. We have teams in 5 countries right now across Africa in the field collecting data to conduct analyses, get results, develop dashboards, and finally support decision makers. The Minister of Environment in Tanzania wants to know where to intensify maize, and we want to help him make that decision in a way that balances trade-offs between agricultural intensification and environmental conservation. And as it is a free and open data set, a lot of our data users are grad students. A lot of people do MA projects around it. So for the grad students here, take a look. So I've gone over some of this already. Why is Vital Signs important? More and more demand for resource extraction, especially agricultural intensification, energy resources, biofuels. How do we meet this demand, help people develop economically without sacrificing the ecosystem services that they depend on? How do we understand the trade-offs and synergies between agricultural intensification and environmental conservation? And this plays in a lot with many of the Sustainable Development Goals, the SDGs. The countries that we work in are very happy to have our data because it helps with monitoring the implementation of the SDGs and helps them monitor whether they're meeting these goals. So Vital Signs works in the countries highlighted in green here, mostly in East Africa, but also in Ghana. And 2 Jeff-funded projects, the Global Environment Facility, use Vital Signs data, and Vital Signs plays a big part in those and works in other related nearby countries. So this is the data we collect. We collect soils data, land cover data. We do household surveys where we ask about household variables and agricultural variables, and we also collect weather data to get sort of baseline climate estimates. The data collection protocols were designed by the Earth Institute at the University of Columbia. So the way we collect data on soils is sort of the standard way, so it can be integrated with other soils data sets so scientists can use it. And this is a sort of example of our data collection framework. This is Rwanda, where we work, and we collect ecological data all over the country. We have e-plots, the large red dots here, all over the country, randomly selected. The data is designed to be nationally representative and representative for each ecosystem, ecoregion in whatever country we're sampling in. And then within each country, we have these landscapes, which are 10 by 10 kilometer areas where we conduct household surveys right next to our ecological surveys. And every ecological survey has 3 households nearby, and that's in these sort of concentrated landscapes, and that's also where we get high resolution satellite imagery that's classified for land cover types, not classified like top secret. And so this is an example of the landscapes. This is where the ecological surveys happen, and then the household surveys happen near the ecological surveys. So we're collecting household data, which a lot of groups do. The LSMS is a big one in Africa, the DHS. We collect this data, but we're also right next door collecting environmental data. So we can see as these human well-being indicators increase, how does the environment look? Are they developing at the expense of natural capital, or are they developing in step with it? Do areas that have more natural capital see greater human well-being or worse human well-being? And these are vital questions. There's a lot of research around how human well-being depends on natural capital, but few people are collecting this kind of data at this scale in this sort of systematized way. So now I'm going to walk you through some of the data sets and what we collect in a little more detail. The household survey data is modeled after the World Bank Living Standards Measurement Survey. So far we've done surveys in 800 households. We look at food consumption, natural resource use, fuel wood use, what kind of possessions they have, housing materials. In a lot of these household surveys in Africa, it's hard to get an income. You can't just ask somebody, how much did you make last year? So a common proxy is looking at, do they own a TV or not? Do they have solar panels or not? Is their roof made out of tin or thatch? Are the walls made out of cement or adobe brick? So we collect these variables. We also get a lot of data around food security and food scarcity, food stability, and we get a lot of individual level data. So education, health and anthropometry, what kind of labor and business enterprises they're involved in. And here's an example of the nutrition data from our household surveys in Uganda. It's a little complex, but each large pie chart is the overall sort of nutrition indicator, and the small pie charts are the sub-indicators of stunting, wasting, and underweight. And so green is good, and light green is not so good, and yellow is very bad. So policymakers in Uganda can get a survey of their country and see where are the hotspots of malnutrition, where are people doing better, and where are they doing worse. And we have this for all 5 vital signs countries. We also collect agricultural data. In every household that we conduct the household survey, we collect the agricultural survey. We ask questions about livestock, animal health, farming implements, extension services, which is trainings from the government and from nonprofits, their sales and income from agriculture, because that's the primary income source in Africa. And we also visit their fields. We collect soil samples in every one of their fields. We ask about the history, the inputs, how much of every kind of fertilizer, how much of every kind of pesticide. These are very exhaustive household surveys. They can take a whole day sometimes. We get farmers' estimates of yields and their byproducts that they use. For our biophysical data, which is designed to be nationwide and nationally representative, we have visited so far over 1,000 field plots. Almost 50,000 trees have been measured and identified. We visited subplots and assessed for erosion and soil quality, and we've identified several thousand unique plant species. And even though Vital Signs is designed to be sort of an integrated monitoring system for looking at how agriculture affects the environment, a lot of this environmental data no one's collecting anyway. So we have people who are just ecologists who don't care at all about human well-being, who just want to know where we saw a given species of tree or a given species of grass. So It's unique because it's an integrated monitoring system, but it's also collecting data in all these different sectors that no one else is collecting. And for the biophysical data, it's all geolocated. For some of the household survey data, there's personal identifiable information issues, so we can't give away GPS points for agricultural field data, but for the biophysical data, it's all geolocated. We collect yields data, so we get farmers' estimates for every crop, for every field. We get their estimates of how much they harvested last year. But for the yields data, for maize and rice, we actually go back, take a systematized sample from their plots, dry the grain, weigh it, and get a very precise estimate of what their yields were. And this is pretty rare to get in Africa, this sort of gold standard of yields verification. Outside of research stations, no one really does this, and especially it's hard to get yields data in combination with data on the field's use history, the soil quality in that area, that household livelihood, well-being variables. We collect land use, land cover data. We have purchased classified or land cover images that the University of Maryland classified in many of our landscapes. We also collect a lot of ground truthing data, which is very valuable for land cover classification. Matt Hansen, if you remember, was emphasizing it's not the algorithm you use so much. He said that was like 20% of it. The 80% of it is your on-the-ground data to verify your classification. So we have teams, in every household, in every ecological plot, and often when they're just driving to the households, they'll stop and get a GPS point and say, this is a field, get a GPS point, this is a forest. And that's really valuable, and that's really lacking in the countries we work in. And again, it's all georeferenced. Finally, we have a lot of soils data from both our biophysical plots and the farmers' fields that we visit. We collect a lot of samples at multiple depths. From the biophysical plots, we release the GPS points. For the farmers' fields, we don't release the GPS points, but that can be analyzed in combination with all of the variables from our household survey. Of those, so far, almost 2,000 have been analyzed by the World Agroforestry Center's soil lab in Nairobi, collecting 52 soil variables, all sorts of stuff around like texture, size, all sorts of macro, micronutrients, organic carbon for carbon sequestration. I don't know much about soil, so it's amazing how much data they actually get from these samples. We know how much tungsten is in every little soil sample that we collect. So that's pretty cool. And we work with the International Soil Resource Information Center, ISRIC, to generate their Africa-wide estimates of nutrients. So in Ghana, for example, they did not have a lot of soil samples, especially not a lot of recent ones, so our data was very useful. They combined this with various other national and continent-wide soil sample surveys and a whole suite of covariates, and did some machine learning to make the best available maps of soil nutrients in Africa. And this is the one for Ghana. And finally, we collect weather data. We have weather stations in each of the countries at a few key locations, verifying all sorts of weather variables, temperature, rainfall, precipitation. Every half hour, using a SIM card and a cell phone connection, it goes from the field in a remote part of Uganda to our database. And the way we collect our data is designed to be integrated with other data sets, so it can be scaled up. For example, we've done work around taking our household survey data combined with our ecological data and looking at household surveys from other people, like the World Bank, and using that to estimate the ecological condition in the places that the World Bank sampled. Okay. So now I'm going to talk a lot about the data flow. So some of you who don't do work at all in Africa around agriculture and the environment, this is probably interesting but not useful for you. Now I'm going to talk about how we collect our data and our sort of cloud-based data infrastructure. So this might be more relatable. And this is what I work on. I'm the data manager, so this might also be more something I can speak to if you have questions about this. So we collect our data using Open Data Kit. A lot of people use it. Forest Watch uses it. It's an open source data kit. It's very customizable. You can collect all sorts of variables. It works on any Android device. So we have field teams in each of our countries, and when they go to these households or these ecological plots, they use these forms to enter the data. And when they get back to an internet connection, they upload it to FormHub, a web application running in the Python framework Django. It's also open source, and we have this running on a cloud-based server. So this collects the raw data from the Open Data Kit forms and hosts it. And then we use applications in Ruby on Rails to bring the data from FormHub into our Postgres database, which has PostGIS enabled. This is all hosted in the cloud on Amazon Web Services. It's a large relational database. And we also bring in data from other sources. So like I said, we have soil samples that we send to the World Agroforestry Center. When they give us back the analyses, we bring this into the database. And our weather stations constantly bring data into the database. So it all gets integrated into this Postgres database, on top of which we put our web applications for downloading the data, analyzing the data. We have an application for data curation, so the teams and other people can look through the data and see that somebody hit 0 way too many times when they were entering the height of the tree and there's no way it's 1 kilometer tall, and they can fix that. We have outputs in R Markdown, so which a lot of our staff are familiar with R, and it's a very easy package in R for quickly visualizing results in HTML and making a quick web page if you don't know anything about web development but you have a data science background. R Markdown's cool. And we also visualize some results in CartoDB, which is a open source framework package for mapping. So Vital Signs was designed to answer questions. Right now we have a lot of data. We're still very sort of supply heavy, and a large supply of data that hasn't been fully explored and fully tapped. But some questions we've already started to answer. What is the value of nature to farmers? Where do people depend on nature? Where do they depend on local ecosystem services for farming and for their own livelihoods? Where should agriculture be intensified to maximize yields while sustaining healthy ecosystems? And what interventions are the most beneficial for increasing the resilience of agricultural production in a time of a variable, uncertain climate future? So first off, the value of nature to farmers. This is kind of a simple analysis, but you ask every farmer, how much of your food comes from the forest versus what you farmed? How much would that food cost at the market, right? How much would it cost to buy a kilogram of beef versus the sort of free kilogram of bushmeat? How much would a bag of fertilizer cost versus soil that's been well maintained and is naturally healthy? How much does fuel wood cost? That's the main energy source in most of Africa is fuel wood, and it's how they cook their food. It's how they keep the lights on, so to speak. That's where they get their energy, and that still comes from local ecosystem services in almost all of the places where we work. And so we look at how much. We try to quantify it. It's kind of hard, but we quantify it in fiscal terms, and we compare that to how much they make off of agriculture from selling their crops. And it's kind of a simplistic analysis, but this gives us an estimate of how much households depend on nature. And this can be subset for any of the landscapes we work in. So if you're managing in Rwanda and you want to look at where in Rwanda do people depend the most on nature, we can do this analysis in each landscape and show, here is where people are still very dependent on local natural resources. If we cut down that forest and put a giant, banana plantation, they would lose a lot. Here is where people are already pretty integrated into an economy where they produce their food, sell their food, and purchase their goods, and they don't depend on local ecosystem services. And this is useful information that many decision makers in Africa right now do based on sort of intuition. If you live in a country, you have a good sense of where the poverty is, where it's not. But we want to help them make this decision in a quantified way. Here is the data to support what the decision you want to make, or here is data that controverts your sort of intuition about the situation in your country. And then another analysis we've done, getting at sort of the original point of vital signs: where should agriculture be intensified to maximize yields while sustaining healthy ecosystems? So first, given current and future population, natural capital, where are protected areas, where's more biodiversity, looking at available infrastructure, roads, agro-dealers, the yields gap, so where, based on soil conditions, temperature, and precipitation, would you expect high maize yields, but we don't think there are high maize yields right now, and anticipated climate change. And we did this analysis for maize, sorghum, and I think millet for the Southern Agricultural Growth Southern Agricultural Growth Corridor of Tanzania. People managing this district wanted our help doing this analysis, and we found that a lot of the most suitable areas for maize were close to Malawi. For sorghum, roughly the same, but somewhat different. And pearl millet, also close to Malawi, but also sort of in the central part of the growth corridor. So, and we're working on an application that will let policymakers weight the different variables in the sort of suitability analysis. So if a policymaker is more interested in the yields gap than natural capital, they can weigh that higher and get a new result for where to intensify maize. If they're more interested in preserving existing forest cover while intensifying maize, because they have sustainable development goals to meet, they can do that. So we want to give them data, and we want to facilitate the decision-making process. We don't want to say, here's the decision to make, and that can be surprisingly difficult because when you're working in countries where decisions aren't often made by consulting the data first, it's a whole new way of thinking you have to introduce. So we found this to be actually a bit of a challenge, is getting policymakers to participate in the data analysis when there's not a lot of technical capacity, so that they can make the decision they want to make based on their priorities, given the data that we've collected. And finally, what interventions can increase resilience of agriculture to climate variability and shocks? So right now, in a lot of especially the Great Lakes region of East Africa, the rainfall has historically been bimodal, which means there's two rainy seasons. There's a sort of long rainy season and then a shorter one at the end. And farmers do 2 rounds of cropping. First, they invest a lot in the long rainy season, and then they'll do some more crops, and then they'll harvest, and then do more cropping for the second rainy season. And right now that's trending towards unimodal, so they're just kind of getting one long period of kind of uncertain rainfall, and that's a real challenge. And how is this affecting farmers' livelihoods, and how is that affecting ecosystems? Well, we're the ones to ask. So we've been doing analyses around this. Here again, in the southern region of Tanzania, we looked at rainfall anomaly for a given year and found that in certain areas rainfall was higher than expected, and in certain areas it was lower than expected. And we modeled this combined with a lot of household covariates to determine which factor most decreased the impact of a dry year. And we found that this was extension services. So areas where farmers had received a lot of support from the government saw the most mitigated impact of a rainfall shortage for that year. And that's when controlling for all sorts of other variables at the household level, like soil inputs, access to NGO extension and other extension services, irrigation access, organic fertilizer use. And this is valuable. If you're a policymaker, this is great information. This says, the work you're doing is working. The extension services are helping. Yeah, so that's the Vital Signs project. Those are some of the questions we've started answering. I think there's still a lot more to come in terms of analysis. We've built up a really great monitoring infrastructure. We have good teams on the ground who are well trained. We have a good cloud-based system set up, but we're still conducting a lot of the analyses. Thank you.